Hello?
Yeah, hello.
Hi. I was muted.
Yeah. Okay. So, how are you doing?
Good, good.
Yeah.
Very good, yeah. How about yourself?
I'm doing good. So we're about to start. Let's wait for some time for some of the investors to join.
Yeah, absolutely.
Okay.
See your face. Go upstairs. They are waiting for you. They are waiting for you. They.
Is it possible for me to screen share? Oh, yeah, right there.
Yeah.
Good, perfect.
We're not sure.
So you said you've been meeting for a couple of months now?
Yeah, we had I think 2 or 3 weeks now. We had the
Okay.
meeting, yeah. So for the past 3 weeks we haven't had another one. So this is the meeting that we are looking forward to.
Okay, cool.
Yes.
That's awesome.
Just hope to see the members just join in so that we can continue.
What was that?
Said we are hoping most of the members will just join in to continue with that.
Some guy we have Congress.
Okay, Nate. Hello. Yes, since we are just, I think it would be better for us to introduce ourselves a bit so that get to know each other quite well. Would that be okay for you?
Sorry, what was that? It's hard to hear with the background noise there.
Okay. The noise.
Oh, your phone. Don't worry. Sorry.
So I was saying, like, since we are just few, I think it would be better for us to introduce ourselves so that we get to know each other quite well.
Okay. Yeah.
So I'll start with myself, and um, I'm now doing mine. I finished my undergraduate studies about 5 months ago. So when you are done, you have to serve the nation for a year. And I chose to work with a software company. And then this is where I'm doing more of Android development. And that's actually gave me the enthusiasm to actually join this community to work with other Android developers in the country and globally. So that's a bit about me for now, and maybe I'll hand over to the next person to also say something about him or herself.
Okay.
Okay. I'm also Samuel Gracious Itiakon, and I recently completed the 100 Basics Nano-Degree program. Yeah, and and I'm also into Android development. Just going to hopefully become much better in Android development. Yeah, to learn more. Yeah,
Awesome.
yeah,
That's awesome, Sam.
yeah.
Very cool. How was the Android Basics program?
Oh, this is very wonderful, very informative too.
Awesome. Very cool.
Yeah.
Cool. Yeah, then I can kind of take over then, and we can walk through this. This actually, like, being really small like this might be kind of nice, because we can kind of we can go through kind of the slide deck, but then also, like, if there's questions, we can definitely chat through, any questions or specifics. And again, since it's kind of a smaller group, like, if we, there's like a question during the slides or something, feel free to jump in. I think there's even like a raise hand feature. I don't know how useful that is. You probably just jump in with a question via voice. It's probably easier. But so yeah, I'll share here. Hopefully, can you guys see the slides now?
Yes.
Okay, awesome. So yeah, today's topic then is Android architecture, and the subtitle here, Freedom Through Structure. And really the idea I want to, I guess, hopefully try and convey just through this is that architecture, there's so many ways to build your app, so many different patterns, so many different sort of architectures that you can apply, that it's really hard to focus on any one specific thing that is best or quote unquote correct, but that having some architecture and having something that works for you kind of universally provides certain benefits to your code that actually, if you're practicing those, you're implementing these things consistently, and it actually provides freedom in your project to move quickly, to build quality features and quality applications.
Okay.
So just a quick little bit about me. My name is Nate. I've been in Android development for about 7 years now, I think. And through that time, have, really developed an enjoyment for writing, speaking, mentorship. I'm sharing on my YouTube channel. I really love events like just getting to chat development in general. And so I'm really excited actually that the group is small, because I think it's easier to get some more one-on-one interaction this way. And then I currently work at Udacity as an Android developer on the mobile app. And so we're going to start a little bit by just taking a quick peek at Android Dev Summit, which was just like a week ago now. And there's a few things that stuck out to me, and in particular stuck out to everybody, which was the foldables. This new sort of form factor, it flat and then also open up as well. It's kind of big keynote for the discussion around it, and also talk about becoming stable and what the app bundle enables, with instant apps becoming a little bit easier, dynamic feature models a little bit easier, just app bundles. And then Jetpack kind of was this large theme as well, where there's just lots of new libraries and tooling coming stable, being iterated upon, and really they're pushing forward this idea of, Jetpack, all the support libraries, and taking a little bit more of an opinionated approach, but then really providing tools to solve a lot of common problems that we've had over the years in Android. And so the reason I mentioned these three things is because they all have something in common, which is they all kind of potentially impact the architecture of your app. These things are all have the potential to change or dictate how you might want to build your app depending on your needs. So foldables, for example, or other form factors such as tablets or Chromebooks with resizable windows, all of these things require you to think about configuration changes or different form factors and how you're going to change your app to fit those devices. Then the app bundles. The app bundles really are great because they make your APK smaller, but then they're also working to make instant apps easier to implement, or supporting the dynamic feature modules. Well, each of those things also requires you to structure your code in a particular way, with feature modules and with having your dependencies separated out cleanly, so you're only bringing in whatever is needed. So again, the architecture is going to come into play there. And then lastly here you have Jetpack, which really Jetpack is a little bit easier to see the connection, because Jetpack is filled with things like the architecture components, which literally have architecture in the name. And so all of these tools then we can use as building blocks to help kind of inform and construct whatever architecture we ultimately choose. And so to kind of frame all of this then, before we get too far in, I pose the question of what is architecture? And this is actually a really generic term, which is why I kind of want to talk about how I want to think about architecture in the context of this discussion, so we're on the same page. And so kind of for this discussion then, think of, the structures, patterns, properties, relationships between all of these things that make up your piece of software. So you might think of it a little bit more simply. It's just like, what structures, patterns, and conventions are you going to use when you build this? How are you going to construct your entities? What will be your decision when you think about messaging between components? All of these small little decisions that ultimately create a pattern that you will then follow as you're building your code. And then why is architecture important? I think it's a little bit telling that as many kind of tutorials, courses, as you're really starting to learn Android for the first time, architecture is not necessarily something that gets talked about really in depth. It definitely gets mentioned, and certainly you're learning things like best coding practices, but there's not as much of a focus on the really high level overarching architecture discussion. And I think a little bit is because it's not strictly necessary. Like, you can build code without a lot of thought or design into how you're going to architect your app. And for smaller projects or small tutorials, it's really not required. But if you're going to move beyond that into a larger scale, production-ready software that you're going to make for and years, then it becomes really important for a few key reasons. And these are kind of what I view as maybe the most important here. I'm sure this is not an exhaustive list, but to start off, testability is huge. If you are going to maintain your project over, like I said, a year or multiple years, you're going to want to be able to validate that the code does what you think it does. You're going to want to validate that as you change that code, that you don't break anything. And so testability becomes really important. And well-architected code is generally more testable. And then with testability comes this idea of maintenance. You're going to support this application for a long-term period. And so you want to be able to easily maintain it. You want to be able to quickly fix bugs, to find those bugs, to make small changes. And again, all of that's easier to do if you are applying consistent, common patterns and components across your code base, and it makes it easier to work with. And then extensibility is being able to significantly change it, add new functionality to it, maybe remove function based on whatever cool new things are coming out with Android every year. And once again, this is easier to do if you are following best practices, if you have common patterns and conventions across your code base, if you know consistently how you are going to build a screen or other features. And lastly, again, if you're using common, consistent patterns and conventions across the code base, the code is easier to understand. You can immediately recognize these patterns and jump from area to area within the code base and know how things are going to work. And all of these things together will enable your team to work faster, to work smarter, to be able to build and maintain code that is more stable and that ultimately is serving the needs of your users in the best way possible. So to sum all of that up a little bit, your chosen architecture is basically going to dictate how you'll build your applications. All of those small decisions will ultimately tell you how you're going to sit down and build a feature, how you're going to ship that out to your users. And then this is kind of that key point once again, that really a good architecture will enable you to move quickly and build quality code. And I think this is one of the key takeaways here today, that while there's often debates about which architecture patterns are best, at the end of the day, we are choosing an architecture for specific reasons of wanting to write good code, ship software to our users. And so I think it's good to remember why we're looking into architecture rather than getting too caught up into which one is the best, depending on who you're talking to. So how do you choose the best architecture? Well, I think it's important to ask yourself a few questions, because really whatever is the best architecture is going to depend on your needs, your preferences, and so there isn't a single answer to this question. So instead of thinking too much about looking for a single clear-cut best answer, I think it's more useful to actually ask yourself a number of questions as you're sitting down to build a project or work on a feature. And a few of these would be things like, how do you want to present your UI? How do you want to actually take data and push it into the view layer so your users can see it and interact with it? How do you want to manage state within your application? Whether that is screen-specific state, whether that is the global state, transient states as you're moving in between screens and deciding which screen to go on if the app comes back from the background. All of these different ideas of state management will come into play as well. How are you going to load data? How are you going to persist that data? Will you be talking to the network? Will you be talking with the database or preferences? How are you going to then expose that to sort of your business logic layer? And then how will you test your code? What types of tests are you going to run? Do you want unit tests only, integration tests, end-to-end tests? And then how will all of these different components communicate with one another? In the Android world, it might be, how do you want to communicate between your activity and your service? Or how do you want to start a job from a view component when it's clicked? All of these types of things, when you start to ask them and solve these individual specific problems, they start to build up what is then the architecture of your app. There we go. And so here's a couple diagrams of of what architectures might look like if you're visualizing it. Particularly the one on the left, the clean architecture. This image is thrown out a lot, and I like it because it does a nice job at illustrating how there are different layers that you can think about in here. So like in this example, you have sort of like your web layer, UI, and then as you start to come down, you can see how components become more specific, and there is a direct communication of those components, ideally in a single direction. And so in the Android world, you could think of this as you might have, some network service that loads some data that then is sent into a repository of sorts. That repository might save to a database, and then your model, your presenter might listen to the database. And in all of these things, there's a very linear hierarchy where data is flowing ideally in a single direction, and you're not mixing your communication between components in too many ways. This makes it easier to trace the data and understand how and when things should communicate. And so kind of the closing point then from this idea of, what is the best, I think, is that there is no best. It's going to come down to what project you're working on, how you understand these things, your personal preference, and then, what tools are available. I think an interesting point to this is, people debate whether you should use MVVM or MVP for your UI layer. However, a few years ago, before data binding, MVVM wasn't really that popular because it was hard to do because you had to manually do all of this boilerplate. And so some of this is then also dictated by what tools are available, what libraries are available to you at the time. So this is always going to be an ongoing changing discussion. And as you learn and try different things, your idea of sort of the best architecture yourself will also likely evolve. So, keep in mind that, we're trying to ship software. We want to make that as stable and as nice for our users as possible. Each project's going to be a little bit different. Your personal preference matters. And at the end of the day, if you can ship good software in a timely fashion, then whatever architecture makes it probably the best one to be using in that moment. So let's look then at a few of these conceptual layers within and look at some of the specifics of how we might handle these layers. So if we go back to the earlier question of how are you going to display information to your user? So this would really be that UI layer. This is actually what's visible on the screen and how we are actually getting that onto the screen. So this is where we start to hear terms that often are associated with architecture as a whole. So MVC, MVP, MVVM, MVI. All of these sort of variants of, a model, a view, and then some other component that is going to control loading data, modifying that data, and then putting that data somehow back into your view. So all of these are perfectly valid. They all have had sort of their day in the sun. MVC was the really popular one as Android was first starting. Then MVP became really popular. With data binding came an increase in popularity of MVVM. And now we're seeing much more interest in more reactive architectures like MVI that are coming from more functional concepts or from libraries like RxJava that really enable these reactive paradigms and streams of data. So again, there's always going to be an evolution here at this level. So it's hard to necessarily say that any of these is the best. One thing that I do want to point out that I think is interesting here is that this UI layer is just one small piece of your overall architecture. So when people get into debates about, well, what's the best architecture for my app, MVP or MVVM, that's a worthwhile debate to have, but it's really just a small part of the entire architecture of the application. And really, if you have a really nice, cleanly separated architecture, you could actually swap out MVP for MVVM or MVI without having to manipulate or change too much else of the code base. So I think it's important to think of these as, very separate layers and recognize that, the UI layer is just one part of the overall application. So another kind of layer here then we can think of is our data layer. So how are we going to load data, and how are we going to pass that data along to the UI layer? So from here, we might start asking ourselves questions like, am I going to need a database to persist data over the long term? And if so, we have things for that like Room or SQLite, Realm, GreenDAO. Are we going to have some type of more transient preferences, in which case we could use, shared preferences and file storage? I'm trying to find the chat window. I saw there was a message, but I don't see it here. Okay, there we go. Anyways, and so then if you start thinking about like where specifically this data might come from and how are you going to use it, you can think of how are we going to structure it? How are we going to communicate with that data? We could get reference to a database directly, but now we are much tightly coupled to that specific implementation. So maybe we want to think of introducing a repository component that masks where the data comes from so that the UI layer doesn't have to know those implementation details. We might also want to interact with the network layer as well, and we might not want the UI layer to know the difference there. So this is where patterns like using repositories or using a single source of truth pattern, where you're always fetching data from the database and repositories or some other component is updating it behind the scenes. All of these decisions start to come more into play as well at this layer. And so you can see now a little bit where each layer is going to have, specific challenges, and you're going to have to solve problems at each layer. And then you're also going to have to think about how those layers will interact. So in this case, you might have your UI layer communicating with the repository, but then there's also going to be a whole lot else happening on each side of that barrier. Okay, and then we talked a little bit about your network layer. If you're going to be loading data from the network, how are you going to do that? So you might have things like raw HTTP requests, retrofit, and again, are you going to mask this in some type of data source or a repository? Are you going to be doing this networking periodically, where you might want some type of job? Does it matter if it fails? Do you need to retry? So again, kind of within this whole layer of how am I communicating with the network, there are going to be multiple decisions as well as multiple tools and libraries to help you solve individual problems. And then kind of one more layer I want to chat a little bit about is what is often referred to as kind of the domain layer, which I've always found to be kind of a confusing name. But you can kind of think of this as your business logic, or whatever the domain specific information is for the problem you're trying to solve. So if you were building an app to display comic books, your domain might be filled with things like, comic book or superhero. You might have models to represent these things. Whereas if you're building like an education app, like at Udacity, we have models that represent things like classroom content or a course or a nanodegree program. And then you have business logic around these entities that says, this is how you interact with these entities. This is how they interact with each other. This is how we're going to model them. And so it's really the stuff that's specific to the problems that you're trying to solve. And ideally, this will be something that stands on its own and that other layers are then going to consume as they're going forward. And the easier you can make it to modify sort of these entities and this business logic, the easier it'll be to maintain these separate layers of the application, because it becomes fewer changes to make. Yeah, so here again, you can think of your model objects, and then you have your business logic, and you'll have to make decisions even here around where will this business logic live, how will you represent that? So maybe this is use case classes or some type of strategy pattern classes that encapsulate behavior, or maybe you'll put that behavior in your view models or your presenters. And then some of these kind of larger things that we talked about at the beginning that aren't maybe as specific to any one layer, but that also are going to come into play as you're thinking about how you're going to build the app is, one is state management. So in Android, this can mean a number of things. We have the state of individual views. So what data is the widget showing on the screen at this time? We also have a little bit higher level, like what activity is present on the screen right now? Which views, larger scale views are present? Are we using fragments? And so we might have a backstack that helps manage this. We also might want to have platform independent state. So what might this mean? Well, you could model your application as a state machine in pure Java or pure Kotlin that represent, what state things in, what data is able, and completely separate that from the Android framework, and then only deal with that at very specific points, maybe when you need to recreate a view. But the idea here is that you'll have to think about how are you going to determine things and be able to sort of query and change the global state of your app. So what screen is visible when I come back from the background, and how am I going to understand that and then repopulate that screen into the proper state? And then another one that comes up that, again, it's maybe not strictly in like a layer itself, but it will have an impact on how you're going to decide to build your application, which is dependency injection. So we have Dagger and Android, which a lot of people use. It's also very complex and complicated to use at times, and it's not the only way to kind of create and share components. You also might use a service locator of some kind and create these objects in a single place and then get them from some common component. You can also create objects and pass them through constructors as well. And this is very valid and is something that should be done in many use cases. And then there might be cases where you want some type of global singleton. I mean, that's often not the ideal way to do things, but there are probably use cases for that as well. But really, again, this is one of those larger level things to consider, is just how are you going to get these individual components into the right places. If you have a view model that needs to use 3 different repositories to load the data and then perform the business logic, you'll have to determine how that view model is going to gain access to those. And then again, all of this you want to make testable. Your architecture is going to have a direct impact on how your components and your state are created, passed around, and stored. This definitely then impacts how easily testable something will be. Decoupled components that have very specific single responsibilities are also easier to test because there's less state that has to be considered when setting them up. And then tight coupling with frameworks and libraries also decreases testability. So thinking about whether you want to abstract those things away through interfaces or through components like a repository so that you don't have to directly interface with something like the Android View APIs or with database APIs. All of this can make it easier to test things in isolation. And then maintenance. So again, like we chatted about at the beginning, you want to be able to maintain the code base over the long run. Well, a good architecture will define very clear components and interactions. So you'll know how things interact across the code base, which makes it easier to understand where things break down. A good, well thought out architecture is going to encourage small, decoupled, and focused components, which again makes it much easier to understand where something is likely failing and then being able to fix that without having to modify too much else of the code. And then again, because the architecture enables good testing, that then in turn makes maintenance easier because testing will find issues before they happen, which means you'll have less things to maintain. And then for extension, if you have less things to maintain because your tests are finding issues, it's then going to leave you more time to actually build new features. And when you go to build these features, you'll have a clear plan in place for how to build them. And it'll make it easier to sit down and build out the feature because you'll already have answered all of the critical questions, like how am I going to display data? Where am I going to load the data? How am I going to manage my state? Another thing I want to point out here is the idea of how do you structure your code. So if you're thinking about having, these different layers, data layer, UI layer, business logic, these all are ultimately going to end up as files, as classes, and you're going to have to somehow organize these. Now, you could just do everything in a large single directory, and that would compile fine, but it would make it a lot harder to read and to understand and then to maintain and extend that code. So there's commonly considered to be, two options here. You could package things by layer or package by feature. And kind of to illustrate the difference here, you could think of package by layer would be these layers we've been talking about. So you could have a package, which is essentially just a directory, and that could represent the UI layer. And so everything related to the UI layer could be in a single package. So all of the view models, all of your custom views could be there. And then maybe you have a database package that is all the different database related code. And so on one hand, this makes sense because related types of things are all there, but then they're also not being surrounded or kind of living next to the components that are using them or are solving the same problems. So that's where package by feature comes into play. Package by feature is the idea that you would have a package for each individual feature. So maybe you're going to build a search feature in your app. You could have a package for search. And then within that, you could actually have a UI package with, all the search related UI components, and then another package for all the search related database components. And in that way, it keeps individual features focused and isolated, which has other benefits, specifically in the world of Android, which we can chat about in a minute here. So here's an example of what this might look like. You have, the top level source directory, and then we have a feature 1 package and a feature 2 package. And then you can see within that, we're still kind of organizing by layer, but now someone could be working on feature 1 and feature 2 completely in isolation from one another, which will let you move more quickly, have fewer merge conflicts, and is just a little bit easier of a way to work. This also aligns really well with the idea of modularized Gradle builds. And this is where then we get back to things like, app bundles, instant apps, dynamic feature modules. Because if we can contain functionality within single modules, that then makes it easier to split those off into these other features. It also makes it easier to have multiple modules, which can have some performance benefits in regards to build time. And it also helps cleanly separate components, which reduces the decoupling that can sometimes occur, which is also a good thing. So that was kind of a lot, and that was all fairly high level, trying to focus in on just the why of this thing, what some of these conceptual ideas are, for example, the different layers. So now let's chat a little bit about the more specific, available tools. Like, how would we actually start to go and think about implementing some of these things? And this is where I think Google has done a really nice job over the past couple of years in giving us not only opinions and a little bit more of a direction on how they think things work best, but then also actually giving us the tools to make those implementations easier. So just point out a few here on the left-hand side. I have a larger full list there on the right. But for example, view models. So the architecture component view model is really convenient to us because it makes the idea of state management easier. It can persist across configuration changes, which means that we don't have to load data repeatedly, which means we don't have to necessarily save as much data. It also means we don't have to reload data when that configuration change happens. And as we have devices that are adopting new form factors, or things like Chromebooks where windows are resizable and we get lots of configuration changes, this all becomes much more important. And so view models are actually an interesting architecture component to me, in the sense that you could leverage the view model in MVP, in MVVM, and MVI. Like, the fact that it's named view model does not mean that it only works with MVVM. You could think of it more specifically as something to persist state across configuration changes. And that is one of those problems that is there kind of regardless of which UI layer pattern you're going with. So the view model is a really useful component. Another one that I like quite a bit is live data. This, again, is solving multiple problems for us. It's giving us a consistent contract of how we are going to communicate data between layers. So you might have live data going from your database into a repository. So that might be crossing one layer boundary. And then also from your repository into your UI. So that can help you give a consistent means of passing data around. That data then also will become lifecycle aware. So again, we're solving this problem of kind of state management, configuration changes, all this stuff that kind of is pushed on us by the Android framework. Live data lets us move away from that a little bit by solving some of that problem for us. And so we can think of, we can just simply say, we're going to communicate this data through live data across these different boundaries. And as long as we sort of hook that up properly, we don't have to worry as much around whether that data will be leaked or how it will be persisted across these configuration changes. Room is another one here. This one is solving maybe not as many problems, but it also solves a very important problem of just making databases easy to work with. So if we think of our data layer in the application again, having Room makes it perhaps easier to decide to go ahead and use, a regular kind of SQL database. In the past, I had avoided using SQL myself, largely because it was sometimes a pain, sometimes cumbersome to set it all up. And when I had done it, it just took a lot of work. And so there were other options out there like Realm or GreenDAO that provided a little bit of an easier solution, while maybe not being quite as performant. But Room makes it much easier to where now, for me, if I'm building something in that kind of database layer, Room is the go-to solution. And again, it also then plays nicely with things like live data, which makes it easier to think about how we're going to connect those different layers of the application. Data binding is another one that I think personally is really useful because it helps solve this problem of how are we going to get our loaded data into our UI. And again, you don't need to use this. You can use MVP or MVI. You could even use data binding with something like an MVI where you're simply binding the data. It's really, again, it's something that isn't tied to one specific pattern, but you can kind of find ways to use it where it makes sense for you. And then if we kind of look at the larger list on the right-hand side, covered a number of these, but then another one to point out is navigation here. This is one of the newer components, and I haven't really had much chance to work with this yet, but from the outside looking in, it's again solving some more of these problems. It's looking at how do we transition between states in the application? How do we track where we're at in the application and transition between these? And it's helping us solve those problems in ways that are easy to integrate with the rest of these components and with the Android framework. And then the last one there down at the bottom, Work Manager, is another one where we looked at kind of that like networking layer when we're thinking about, how are we going to communicate these kind of periodic jobs. The Work Manager is another really useful solution that helps us kind of not have to spend as much time debating about what is the best way to do things because we have this ready-made component. And so I think that's just one of the things where I really like what's happening with the architecture components because it's letting us not spend as much time having to debate all the different solutions for these, and giving us really nice ready-made tools that we can immediately turn to start solving these problems. So again, all of this stuff we chatted about, want to iterate again. There's no wrong answer. If you know MVP and that is how you like working at the UI layer, go with that. If at the data layer, your application isn't storing much information and you want to use preferences rather than integrate Room, that's fine. Remember, at the end of the day, you want to use what works best for you, what makes sense for you, and what is going to enable you to build the application that is going to solve the needs of your user. All of that said, I also wanted to give you maybe some context into the specifics of what I use and just some of the kind of the problems that I have solved in some particular ways. So at the UI layer, and again, this is, should preface this by saying, this has been an evolution. This is not what I have always done. This is what I'm doing kind of right now. And I already have ideas for how this will probably change for me over the coming months. But kind of what I have been doing right now for a while, at the UI layer, I've been using MVVM with data binding. So I use the architecture component view model class to kind of contain the business logic for different screens. That view model is using repositories that typically are implementing a single source of truth pattern, basically meaning that my view model will have a repository and it's getting all of its data directly from that repository. It doesn't know where the data is coming from. The repository then is free to load data from the network, from preferences, from the database, and it's completely transparent to the UI layer. For a lot of things, the repository ends up subscribing to Room via an RxJava flowable, and then other components can save data to the database. The repository gets notified of that, and then the UI layer gets updated. In terms of messaging across layers, we use a variety of approaches. So this might be like observable fields, RxJava observables, or Android framework intents too, to communicate messages across layers when needed. And then, like I mentioned, for database, I've been using Room. I really like what they've done with that, and I think it's very easy to use nowadays. For networking, we're using Retrofit for our HTTP requests, and then also have used kind of priority job queue library, but then that is getting replaced now by the job manager, and that will be what I use kind of for the foreseeable future. And then for dependency injection, I use Dagger, but like I said before, it's pretty complex at times, so I'm not always overly happy with it. If I was going to start a Kotlin-only project today, I would probably look at something like Coin, which seems to be a little bit easier to work with and a little bit lighter weight, and I think is easier on the build times as well. But like I said, all of this will continue to change as libraries and tooling change and improve. We will adapt as developers to use what works best at the time. And so I want to also point out just the Google architecture samples. If you're not familiar with this, you can search for Google Android architecture samples, I think, and they have a repository with a bunch of branches that basically illustrate different aspects of this. So they might have something like MVP and then MVVM and MVVM with data binding plus Dagger. But basically just a lot of patterns here to show how certain aspects of architectures can be implemented and how they can work together. And it's not an example of this is how you should do it, but it's just an example of a number of different ways that they can all work together. So with that, I talked about a lot of stuff, and I know we're kind of a small group, and if we have time, I would love to just answer any questions we have. And I guess maybe before we kick it over for that, we'll just say, like, if you want to get in contact with me, you can find me like on YouTube, or Twitter is probably like the best place to find me. Facebook, LinkedIn, But I really do love to just chat and answer questions about all this stuff. I'm definitely, learning as I go in the same way that kind of everybody else is. And I do enjoy and try and actually get back to everybody when they ping me, and oftentimes those lead to some interesting discussions. So feel free, if you have questions, today after this or in the future, feel free to send those my way. I'd be happy to chat. So I think with that, if there's any questions about, I guess, architecture or other things, I'd be happy to help answer any of those. Hey, hello. Hey. Let's see. I see one question in the chat, which is, where can we learn these architectural components in depth? So that's a really good question. So the Google architecture samples are probably the best resource I know of, because they are using a lot of these architecture components. They also get into things like dependency injection, as well as the different sort of like UI architectures. And they also have examples, I think they're using things like RxJava or live data. So you see different examples of how to solve the same types of problems. So I think that's probably the best overall resource. There's also, you can find resources out there for, comparing like MVP with MVVM. So you can, compare some of those different things at the UI level. I don't have a specific one for that. I know, they're not too hard to find though. And a lot of them have been pretty solid. For the larger like architecture as a whole, I haven't found too many great resources on that. The one that comes to mind is there's a book called Clean Code, I believe, which I left there in the chat. So that book does dive into architecture as a whole. It's not specific to Android at all, but it does a really good job. I've had a lot of people recommend that to me. A lot of engineers that I respect and think understand architecture very well. A lot of them have taken that book to heart or even gone through trainings from the author. So I think that was another really great place to look for just general information about software architecture, which obviously then translates well into building Android apps. Are the architectural components Kotlin based? So no, I don't think any of them are written in Kotlin. It's possible, but I don't think so. However, there are like the Android KTX library, which is filled with a bunch of Kotlin helpers, basically. I do think there are some functions in there that make working with the architecture components in Kotlin easier. So no, you can definitely use the architecture components with Java or Kotlin, but it might be a little bit more convenient to do so in Kotlin because of those extra helpers. Let's see, another question from the chat. Dagger versus Parsable. Do they do the same things? Super confused about dependency injection. So yeah, there's a couple good questions there. So, Dagger versus Parsable, do they do the same thing? The answer there would be no. So Parsable is kind of like serializable, which is this notion of being able to take an object and basically write its state out into some other format. So you could imagine kind of similar, like you could write it out to JSON. So this might be writing it out to a byte array, which can then be easily saved out to some type of memory, so that when, let's say, the device rotates and you have a configuration change, you can then take that byte array and reconstitute it back into the original object. Another option where you might want this is if you have some object and let's say in activity 1, and you want to pass it to activity 2, because of the way the framework is constructed, you can't just like pass boundaries like that. You're limited in what you can pass kind of in the intent system like that. And basically the way sort of you get around that is, again, you can implement a parseable, which gives it a very simple interface which to write out that data and then reconstitute it back on the other side and possibly what could be like a different process. Now I say simple because, you know, it's at a high level, the process is simple. Implementing parsable is not simple. There are things that make it easier. Like there are plugins within Android Studio that you can use that will generate that implementation for you. And then if you're in Kotlin, you can use the parsalize. But so that's really what like parsable is for, is basically a way of kind of serializing or basically saving out the state of an individual object so that it can be reconstituted across, you know, a configuration change or, you know, an app reload. Dependency injection then is more of a larger concept that isn't specific to like Android or Java. And it's really the notion of basically being able to have an object have its dependency passed into it rather than creating the dependency itself. So maybe a more concrete example here would be if I have an activity and my activity is going to use a view model to load the data, do the business logic, all of that stuff. The activity could create the view model itself. But that also means that if you want to test that, it's harder to manipulate the view model to set the state up to test because the activity is the one creating it. It also means that if you want to change how that view model is created, or maybe you want to pass in, instead of a release view model, you want to pass in a test view model, you have to modify the activity itself because the activity is the one that's creating that. Dependency injection inverts that. That's another phrase you'll hear in regards to dependency injection, which is inversion of control. So instead of the activity creating it, something else creates it and it passes it into the activity. So now if we look at those previous examples where, well, if we want to test this and we need to set up some initial state, we can create that, set up the state here, and then pass it in. Or we could create, you know, a derived class. You know, we could subclass it and create a test state and pass that into the view model and then into the activity. So that's kind of what dependency is in a nutshell, is really kind of passing in those dependencies, inverting who is creating them, which then makes them less coupled and easier to manipulate and test. So the way Dagger plays into this then is Dagger is a tool to basically make it so you don't have to manually create all of the dependency injection framework. You could write your own dependency injection tool, and it's would be a time-consuming and tedious thing, but it's also not really like that complex of a notion. So you could do it if you spend a little bit of time and effort into thinking about it. It's just a time consuming. So Dagger basically aims to generate all of that code for us and make it a bit easier. So for example, I mentioned Coin as a dependency injection option for Kotlin. Coin kind of solving the same type of problem, but in a different way, and kind of in a way that I think looks a little bit less scary than Dagger does. And so you can see like there's multiple tools out there for dependency injection. So dependency injection is kind of the concept, whereas Dagger is the specific tool. What are your go-to testing libraries? Mockito, Espresso? That's a really good question. So mostly Mockito, or also I've used PowerMock in the past for if I need a little bit more powerful of a mocking tool. If I'm doing UI testing, I have used Espresso, and that would probably be the one I use. Admittedly, I haven't done as much UI testing lately as I would have liked to, so I'm a little bit out of date there, but that is still kind of the go-to tool that I would suggest. Also, Roboelectric you could use if you are wanting to sort of unit test things that implement or touch on the Android framework. It can be a little bit easier to use Roboelectric for some of those types of tests rather than using something like Mockito to have to mock out any of those Android framework objects. So those should be the big three that I would consider: Mockito, Espresso, and Roboelectric. I think Roboelectric 4 is coming out soon, which is supposed to provide some nice benefits as well. So that's probably something worth looking at. How to start learning architecture components. Is there a specific approach to go about learning them? Because they seem, because there's a lot of them, basically. Yes, that's a really good question and observation. There are a lot of architecture components. I mean, I think that little graph or that little image I shared, I think there's like 10 plus things on there. And so, yeah, that's very overwhelming. And I think the best way to go about it is to pick one or two at a time to consider and start to get an understanding for how they work and what problems they solve. So this is, again, where I think the architecture samples that Google have is a good place to start, because you can start to read some of that code and understand how they work together. And then you could think about, trying a couple out at a time. So like a good example of that might be if you want to understand how you could use these things at the UI layer, you could pick, maybe the view model class, and then you could look at maybe data binding, or you could do them completely separately. You could start and just look at how the view model class works and how you could use that to implement MVP. And then maybe if you want to do MVVM, you take the view model and add data binding to it and see how those interactions work. And then you can kind of, I think, do that to build up your understanding. Some of them stand a bit more on their own, like the Work Manager, for example. That one is a little bit easier to try out in isolation. Things like Room or paging start to be a little bit harder to test, but like even Room, like you could use Room to generate your database and then test that with any other piece of code. You wouldn't necessarily have to use a view model or anything else. So I think just trying one or two at a time and working to understand the problem it's trying to solve first will help before trying to dive into a full project and understand all of them at once. Because like if you try to take on view models and data binding and Room and the paging and the navigation component all at once, that would be overwhelming. Like, that sounds overwhelming even like to me. I think it would be to like anybody who start throwing in too many new things at once. And then, yeah, in terms of places to look for those things, I think the architecture components samples is a really great resource. There's also some really good posts on Medium from some of the Google DevRel team about some of these things, like Room and live data in particular have some really good posts. And then kind of a plug here, although like I didn't work on it at all, but I do think the new sort of like Udacity course that was announced at Android Dev Summit, I think that is getting into some of the architecture components, and it's all done in Kotlin. So if you're looking for kind of a way to get some Kotlin too, I think that resource is available. But yeah, sorry, that was kind of a long-winded answer, but yeah, there's a lot of those components and a lot of places to kind of look for that information. But the architecture samples, I think, are the best spot to go to first. Comment about great to start doing some tutorials on YouTube channel as well. I agree. I would like to start doing that. In particular, I have some ideas planned for doing some examples of like an MVVM UI layer using data binding. That's probably where I will start. But yeah, if there's other types of ideas, like that anybody has, feel free to send them my way. Because I basically I want to spend time, trying to help people learn stuff that they're interested in. So yeah, something like this, very specific, is awesome. Thank you for the suggestion. Cool. All right. Well, yeah, looks like that might be it on the questions. Yeah, again, if anybody wants to chat more, best place to get a hold of me is probably Twitter. There's my Twitter handle right there. But yeah, I'd be happy to chat in the future. Thank you so much for having me. This was fun. I'm glad we got to kind of go through all the Q&A at the end there too. That was awesome. Cool. All right, everybody.
Yeah, thanks a lot for your time.
Yep.
We learned a lot. Yeah.
Awesome. Awesome. Thank you so much.
Yeah.
Cool. All right.
Yes. Hello.
See ya.
Hello.
Another time.
Oh.
Yeah, sorry about the mic, guys. I actually didn't see it on. So
Yeah.
Oh yeah.
I don't know.
I intentionally turn off the video. Hello. 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 Hello.
Yeah.
Yeah, I think the network is quite bad. Can you hear me?
Yeah. Yeah.
Hello.
Yeah.
But it's like someone's network is bad at his end, so
Yeah. Okay.
it lacks.
Is it Nitani or Nitan, right?
Yeah. This Nathan.
Nitan. Oh, okay. This is my first time.
I mean,
Actually.
my face is not showing.
Is it? Maybe can you share the screen as for us?
I'm trying to share, but I'm
Yeah.
getting. I'm coming. Let me.
Okay.
Yeah.
I think this is my first time of seeing you. Yeah. Oh, you've met it before.
no, we haven't met before.
Oh, okay. Also, are you based in Ghana?
I got the link from a friend. Yeah.
Oh, okay. Well, nice.
Yeah, I'm based in Ghana. I'm currently working as an Android developer.
Oh, nice. For which company? Oh, you just working for yourself?
IT consulting.
Oh, cool.
I work for IT consulting, but I also do freelance. So.
Oh, okay. Oh, nice meeting you today. You have to get in touch, right?
Yeah, nice meeting you. Yes, sure thing. I'll leave my phone number in the chat.
Okay.
Thanks so much for that.
Okay.
I was having
Alright, so
that's why.
anything else, just let me know, okay?
Okay.
Have fun. Take care.
Okay. Nice time with you.
Bye-bye. You too.
This is someone I know you. Ebel. Samuel, who is Saloko or something? Okay.
Yeah. I'm a friend of Samuel.
Okay.
He made me join your group.
Okay. Awesome having you today.
Android enthusiast.
Oh, cool.
Oh, cool.
Nice.
So Samuel is my boss. I'm learning from him.
Okay. Small. That's
I'm working at teachers. I'm working at teachers and what I'm right now. I'm trying to focus on my web a little bit because I'm getting it difficult for people to develop the web parts of my Android projects for me.
Okay.
So it's like I'm getting heck at that place. So I'm trying to develop that place well for me, like me myself, so I can develop my Android app. Because when I tell people to assist me in that, I get
Oh, really?
Yeah.
Okay. Awesome. Nice having you guys. Like, I think we have to do more of this, but we have to get maybe a good representation of our numbers so that those who come in to, share with us will also be motivated.
Yeah, you go.
Yeah. Thanks for it.
Android, your name?
Is that
Your name.
okay. My name is Oliver.
Oliver, okay.
Yeah.
Where are you?
Oh, so I'm just doing my national service, so it's a company.
Okay.
Agrinova, so they are more into this agri-tech stuff. Working on it.
Are you doing Android as
Yeah.
side or you are doing it there? Like you're an Android?
Yeah, I'm doing Android. Yeah, I'm doing Android over here.
Okay.
Yeah.
So I hope everything is cool.
Oh, everything is going on well. Pretty much well.
Oh, nice. Well, you don't worry, I'll chat you up. If anything, no.
Okay. Thanks for joining.
Bye.
Yeah,
Samo, why you laughing?
Boss Bekun.
You, Oliver.
Yeah, what's up?
Charlie, cool.
Charlie. You show me a 1-2-1-2 kakra.
Oh, what was the question, Charlie?
Hey, Charlie. Why you saying at least no?
Say, you been another one, right?
Yeah. You are trying to maybe speak to other group of people. Say they'll get some time. Yeah. I just have to compile some email be for Thanksgiving and gratitude because of his time. And I hope you learned a lot from this because as a name or chair but like it's
that's Udacity, yeah.
Yeah, he's working for Udacity.
Wow, Charlie.
Yeah. Charlie, that's awesome
All
time.
right.
Yeah. So I have to go and get to him within some few minutes. Yeah. Thanks for.
All right, Charlie.
Yeah. Okay.
All right.
Yeah.
Charlie, later, bye.
Yeah, Matty.